Welcome to the Connect with BMC Helix ITSM and Remedy webinar. During today's presentation, you're able to ask questions via the chat window, and our panelists will answer them. This recording will be posted a week from today's live presentation, and this month's presentation will be on reactive to proactive end-to-end service management. To take us through this content, Darius Wallace, AVP Solution Architect. Turning it over to you, Darius.
Thanks, Greg. Welcome, everyone. This session of moving from reactive to proactive with end-to-end service management, this is intended to go beyond just the concept and the theory of being more proactive in the activities that you do and being more stable in your environment. We're going to be looking to give you some tangible steps to take, some approaches that allow you to connect knowing what you have in your environment all the way through to your operations and governance side to be able to get in front of things before they happen and before your end users experience outages. With that in mind, let's go ahead and jump right into it. We're going to start off kind of giving the big picture, laying the foundation for some of the key concepts that we'll be talking about. We'll introduce some building blocks that contribute to getting the results of moving from reactive to proactive. And then how do you shift left? How do you move from a reactive mode into a mode where you get in front of things, where you start paying attention to degradation of the environment before your end users experience outages in the environment? There'll be some other items that are dropped in as keynotes for best practices, and then also some practical lessons learned from experience with customers who have made this journey. Now, the last two bullets will be sprinkled throughout the session. This agenda is not designed for it to go in this order. Throughout each of these segments, we'll drop in some of the best practice ideas and some of the practical lessons in the context of the concept that we'll be focused on at that time. So let's go ahead and get started with the big picture goals. The key thing to note here, let's do a level set. Looking at the environment, a lot of times customers start with an incident solution and they're in the break-fix mode. Great place to start. It allows you to get a structure and some organization principles in place. But oftentimes, customers spend a lot of time staying in that mode and just getting efficient about how fast they react to things that go on in the environment. And what happens is, the more you cover with your service management capability, with your service desk capability, end users run into situations and experience outages as a result of failures in the environment. The team gets really good at trying to get their hands around it. You start adding more resources, so as more problems come up or more issues come up, and you start seeing these outages or these impacts to the environment, those folks become very good or effective about fixing things in that break-fix mode. But that puts you in the mode of reaction. Something happens, you react and go fix it. Our goal is to look at things from the end user's perspective and move to a proactive mode of operation. In other words, you want to get in front of things before the customer even experiences any impact to what's going on. More specifically, you definitely want to get in front of it before they experience an outage where they can't get any work done. So to that end, we're looking at the fact that we want to move from reactive and shift to the left. Now, the way we've laid this out is with the intent that these are things that have happened on this timeline. First, an event occurs, and you may have no clue or be aware of the event because it just happened in the environment. And eventually, as time marches on, it either progressively gets worse or has an impact on other things, and there's a tipping point, and it leads to an outage, and that becomes the next event. So this session is really about how do we move and shift to the left to get into that zone of being proactive, catching things before they result in an outage. And that puts us in that proactive mode. And one of the first steps there is to move into what we refer to as that degradation zone, which means that something is starting to not perform at the levels that are expected. And with that awareness, you can proactively address that issue before it becomes detrimental and you hit a tipping point and it leads to an outage. So our first goal is to get into that zone. And there's several steps that we'll talk about things that can be done in the solution and the approaches that you take in order to move into that zone. And then all the way to the left is when you start talking about getting in front of issues before they even become events. So by the time we're done with this session, you'll have that progression and all the different steps that you can take to move that needle to the left. So the key thing here is to have proactive outage mitigation. The goal here being that you want to get in front of things before they become an outage. Again, the thing to emphasize in this first scope or this first level of capability is looking at it from the perspective of the end users. As you get more mature, you start getting into the point of looking at things from the perspective of your own operations to say, how do we get in front of things before your operation teams need to even react to the fact that you got an alert about a degradation. But that's the next level of evolution. Right now, we're just starting with, from the perspective of the customer, there are going to be things that happen in your environment at the time that the event occurs. How soon can we capture it, detect it? That event may be the beginning of a degradation. Customer may be running perfectly fine. You want to be able to rectify that situation, get it back to normal, and the customer doesn't hit any speed bumps along the way. The inverse of that is that the customer experiences an outage and you don't even know about it. That's the extreme. The time that you know about it is because the customer calls you and tells you, I can't do something. In that case, whenever that happens, your customer, in essence, was your event management system. They're the ones who detected the event, and they're the ones who told you that there was a problem for you then to react and correct the problem. And that's the very thing we're trying to avoid. As I mentioned earlier, one of the key goals for certain areas, we may even get as far as being able to get in front of issues before they even become events. We'll talk about that later. So one of the key things that contributes to effectively performing within this area that we refer to reactive is your incident management system. That's where you're doing your break fix. But if that's the only tool that you're leveraging, that's the only process that you have in place, it's sometimes very difficult to move the needle to the left with just that process alone. Supporting that process, you want to understand that you have some foundation information. You need to know what you have in your environment so when things go bump in the night, you know what it is and therefore understand the best approach to get in front of it and repair it or get it back up and running. So as we want to look to move into that proactive mode of operation, get closer to that degradation zone, this is when you're trying to combine things together as far as processes and capability. Event management is a very effective tool in accomplishing that. So let's look at some of the key building blocks in order to move that needle to the left. We talked about service management, including incident change problem, but a lot of customers are in the point of trying to deal with moving from reactive to proactive are stuck in the mode of just leveraging the incident management activity in order to stay tight to the break fix operations. That translates into, as we said before, a cost implication because you hire more people to just fix things faster. But it's key because you want to document and still govern things that go wrong in the environment so that you can find your opportunities to improvement over time. What really helps you feed into the service management process is establishing your system of record to reflect what is in your environment. Knowing what's in your environment allows you to establish the context so that when things go wrong, you can focus your attention on getting that back up and running. If you're doing it based upon what people think it's out there or a customer telling you, I can't do X, Y, Z, then, and you don't know where that is, what the intended state of the infrastructure that's supporting that customer's functionality makes it very difficult and takes longer to resolve the issue. So let's shift this into a mode going from left to right, taking into account what happens in the environment. You have the end user sitting out in the environment, or you have your service desk agent sitting there and doing what they do and waiting for calls or working issues that have already been reported. An event happens out in the environment. At this point, let's just say the event's happened. You don't know it yet. The memory on a system starts to increase or get to a certain threshold to a point where the infrastructure item, the server or whatever it is, starts performing below its expectations. It gets to a point, because you didn't know that this was going on, that it hits a tipping point and ultimately some element of your infrastructure goes down. As a result of that, that impacts the end user, who then picks up the phone, gives you a call at the service desk to say, I'm broken. I can't do X, I can't do Y, I can't do my job, or I can't get this function done. Therefore, they've experienced the outage. They have operated as your event management system because they're the ones who first became aware of the event and they told you at the service desk what was going on. You then open up a ticket, identify what the item is, and then you start working the item. That puts you into that reactive mode of operation. What we want to look at here is having awareness of what's going on in the environment. What do you have in your environment? And we want to establish that system of record by first doing discovery to find out what's out there, and then populating your CMDB with that awareness so that your downstream solutions can consume that system of record for what's out there in the environment. What we would then look to do is introduce event management so that when something happens in the environment and you have the context of the CMDB or the system of record of what's in your environment, when an event occurs, you can associate that event with the record, the system of record for the item that's in your environment. Now in this mode, with this setup, with this configuration, you now have that information available so that when something goes wrong in the environment, your event management system, which is monitoring what's going on, is able to detect that, associate it with the item that has had the problem, and it then creates the ticket. And the expectation is that happens before the end users realize there's a problem and calls into your service desk. With that head start, hopefully with enough lead time, you're able to fix the problem, restore service, or get it back to the levels of performance you expect, and the customer doesn't experience an outage or hopefully even a degradation. So let's adjust the model again and kind of expand in each of these different areas, the functions that support and the elements that support this capability. So off to the left, as you see, we have automated discovery. The operative description here is automated discovery. It's very important to understand that the success of what you do here ensures that you have automated discovery implemented in your environment. I'm not speaking specifically to a specific tool. I'm just saying that things change too much in the environment. Things are going in too dynamic in the environment to rely on manual entry to put things and keep up with how things are changing in the environment. And it doesn't mean that there aren't some activities that get loaded into the system for your system of record for the configuration management system for your CMDB that don't come from importing information from other systems. But this is emphasizing automated discovery also leverages solutions or technology that tries to keep up with the dynamic nature of your infrastructure. So that information feeds the CMDB, establishing your system of record. As we pointed out here, the event management solution would leverage that system of record to establish context so that you have a representation of either the CI itself or the infrastructure item itself, or a model that also goes to the point of showing the relationships between those items in your environment. So if something goes wrong here, you would understand the impact to the upstream item that's dependent upon it. And then ultimately, when that detection occurs, you would feed that into your service management solution by creating an incident, which would allow you to take advantage of your operational governance to tie into knowing what the impact is to a given asset, who that may be impacting, and kick in your change processes to affect change to fix the problem for things that require a more involved effort to put those solutions in place. So what we tried to do in this first segment is try to establish the baseline to understand how these things come together, those basic principles. One of the things that I want to emphasize here is that you do not want to do this activity in a silo. What I mean by that is that I talked about different areas, practice areas. There's a discovery practice. There's a configuration management practice. There's an event management practice. There's a service management practice. It is not uncommon for each of these processes and each of these practices to be operating independent of each other. The ability to move from reactive to proactive is the coordinated effort between these practices. Knowing that you have event management who is trying to establish when an event occurs, what a CI it's associated to, and what it impacts upstream, helps you establish the scope for your focus for what you discover in the environment, what you want to represent in your system of record in the CMDB, so that when event management consumes that, it is very targeted so that you can get the results for the benefit of your consumer. As an example, if I'm looking for an area such as finance, and finance has an app that's critical to the company, then I could readily start there and say, let me make sure I understand end to end what's in my environment supporting the capability of my finance organization. And that would then focus the scope of what you discover to get that result represented either initially as just CIs or represented as a form of a model, so that the event management system can say if something goes wrong with any of these items in the environment for these CIs, I know it has a direct impact on my capabilities with regard to the finance organization. That allows you to tie end to end and focus the end-to-end flow. So that's why you don't want to do these things in silos, because you don't get the results you're looking for, right? You want a coordinated activity and effort so that you have those teams working together to get the results that we're talking about moving from reactive to proactive. As I mentioned before, service management is insufficient, or having incident management insufficient alone to get you from reactive to proactive. It depends upon automated discovery. And one of the key things is that you don't have to just jump in and rely upon one solution providing you information. This last bullet down here says you have a whole set of information already in your environment. Somebody's managing it. All you're looking to do is start with that and maybe leverage that information, those CIs, the things that you have in your environment, and use those items to populate your CMDB.
Darius, I have a question from chat. The question is, we are just getting started with automated discovery, and we have scripts to automatically import CIs into our CMDB. Is this the level of automated discovery you are describing?
Yes and no. Let me give you the yes part, but it's more than that. The yes is any information that you can pull out of the environment and get into your CMDB for your system of record in a reliable and consistent way is definitely a good start. And when you automate that so that it keeps up as best it can to the things that are changing your environment, especially even if that's just from Excel spreadsheets or files or documents, and you drop it into a directory and you have something that automatically picks it up and feeds it into your data set, which feeds your CMDB, that's all good. But the larger opportunity is when you're leveraging a tool that's actually scanning your environment, scanning your infrastructure, and is running on a regular schedule with the ability so that when changes occur in your environment, not necessarily at the time that the change occurs, but within a window of time that's reasonable, so that when that change occurs, you pick up that change and have that flow into the system. That doesn't require any human intervention. It's leveraging the discovery technology that is out there scanning the CIs or scanning the portion of the infrastructure that you're focused on. Let me say that last part again. Scanning the portion of the infrastructure that you're focused on. I say that because in the early stages, depending upon who's consuming the information and getting the benefit from the service or the area that that the consumer is benefiting from, you may decide that you really only want to do this for your data centers and get that done well to make sure those data centers stay up and running because of the scope of the apps that are covered there. After you've done that, you may want to expand to other areas to understand what's going on, such as desktops or things that are in areas that are outside the data centers. So the key thing here is make sure you pay attention of the scope of what you're working on. Put in automated discovery to get that piece of information flowing into the CMDB. And more importantly, leverage your consumer. Identify who your consumer is to determine what it is that you're going to focus your discovery on. You can always expand it, but the big bang of let me just discover everything, put it in the CMDB, and then any consumer can benefit from it because it's all there, does not work. It fundamentally does not work. Because what you put in the CMDB and how you put it in the CMDB and how you go about scanning the certain areas to put it into your system of record has to be done in the consideration of how the consumer is going to leverage it and benefit from it. There's more about that can be talked about in a totally different session around best practices around the CMDB. But what I meant by that automation was more along the lines of having a tool that does discovery across your infrastructure on a regular basis and with full scanning to pull that information in. Okay, let's go on to talking about our next area that will make a difference in moving from reactive to proactive. And we introduced event management. What we're going to do is talk a bit more about how we evolve our ability to detect things going on in the environment with the event management capability. So as I mentioned, event management is a key component to moving that needle from left to right. So let's look at a few ways in which we can evolve what event management does in order to make that needle move. Most times customers come in and they leverage event management to look at things in the infrastructure. So we tend to refer to this as monitoring at the infrastructure layer. You look at the operating system components, you look at the database, the network, you look at log files, and you start looking at the CPU on a server. You look at the amount of space that's being used in a certain storage area or on your disk and your storage capacity. You may look at certain aspects about how the database is performing and how the operating system is performing with regard to memory. So these are common things that come in and are definitely an incremental or a beginning step to get that net out there for coverage when things go wrong. The next level that allows you to get even further insight as to not only when something goes wrong, but have the context of when something goes wrong is when you start looking at application level monitoring. What this is talking about is every application has certain elements of it that support that application functioning. The most obvious example is that all applications have some service or some process that's running in the environment or something that's specific to that application to enable that application to do what it does. So being able to monitor the service running on a server is an example of having monitoring at the application level. But let's go a step further. Knowing the application, this is where the application managers and people who are the subject matter experts for the application managers are key. There are certain choke points that could occur within an application. For example, there may be a table that's used to manage a queue of requests. And things go on the queue, things come off the queue. And for whatever reason, if that queue ever has anything more than, let's pick a number, 50,000 items in it, the system starts running sluggishly because it's taking time trying to clean that queue because it expects there to really on a good performing system to never have more than 5,000 to 7,000 items in it. So what you would do in this case is, knowing that this is a table that's managing the queue, which is critical to the app, you may find yourself putting in place a monitoring to say that whenever this table gets more than 7,000 items in it or 5,000 items in it, or in the case where you know it tips over, say it's 50, you'll pick something at 10,000 and say, if it ever gets more than 10,000, I want to send up an alert because I know that queue has a direct impact on my application's performance. Log files are another area that's a great example. Each app has their own way of logging information in the system. It's amazing to me sometimes when I work with customers that they don't pay attention to error codes that pop into log files. They may be warnings or they may actually be critical alerts that are just saying something went wrong, and it may recover on its own. But the point is, if that's dropping in there on a regular basis, that's an example of having a degradation or being able to detect something and get in front of it before it becomes a larger issue. So knowing the app, leveraging your application managers who understand the architecture and the structure of the application and putting monitoring around those components is very important in order to improve your detection for your event management solution. And another area that really is a double-edged sword. In-user simulation, synthetics, actually is very helpful, but most times what you're doing with synthetics or the simulation is you're getting a visibility for what your customers are experiencing. And it does move the needle to the left a little bit, but sometimes not that much. It's really just giving you 10 minutes before the phone rings from the customer, because you've got this automated thing repeating what the customer does on a regular basis. It found that it's slowing down. And if it's slowing down, probably within 10 to 15 minutes, maybe an hour, the customer will deal with it for a minute before they actually pick up the phone. So it's just giving you a heads up that customers are about to call. Usually that 15 minutes or that hour is not enough for you to figure out what happened, why it's slow, and get it fixed before the phone rings. So it's just, it's just an early warning system that somebody's about to call you, not an early warning system that this is the area where something's wrong and you've now got to address the degradation before you have an outage. It's more, hey, here's a heads up, customer's about to call because I'm experiencing slowness, which is similar to what the customers are likely experiencing. But that doesn't mean that end-user simulation is not invaluable. When you're looking at things after the fact, it becomes a very valuable tool to go back and do analysis on your performance of your synthetics, especially when you're trying to establish baselines for before and after. Right? So this is just a part of that equation that you put in place when you're starting to look at your monitoring coverage. Another area to consider is being trying to be more evolved in how you establish your thresholds for when you trigger an alert. In this particular case, static thresholds mean that you say if the CPU, as an example, goes above 80%, then I want to trigger an alert. That's a generic static threshold. Going above 80% may be perfectly fine on Monday morning when everybody's coming into the system, logging in and performing a common function across a division of the company. The system is still okay. It did get up to 80, 81%, but it didn't necessarily lead to a failure. And then other times during the day, it may actually turn out that on a Tuesday or a Wednesday, the threshold never reaches 80%, and yet you still get a failure. And that's because if you look at this next example, what you want to be able to do with what we refer to as dynamic thresholds is know what's considered normal and then focus on the things that are operating outside of what's considered normal. So in the first example, 80% may be normal. But let me give a better example and look at the case that says, if I set my static threshold at 80%, on this time of day, this day of the week, whatever the case may be, 40% is what this should normally be. That's what we've seen over gathering the data over a period of 3 to 4 weeks or 2 to 3 days. That's normal. When something goes to 65% at a time when every other time it's 40%, that's an abnormality that you probably want to pay attention to. And because of that abnormality, you would then be able to react to it, get in front of it, and address that something may be going on, and it is the precursor to something hitting and going above the 80% threshold, which then leads to a failure or something that's more catastrophic. So having dynamic thresholds in a system that can establish what is considered normal when, and then paying attention to when things deviate from normalcy, is an example of being able to get ahead of the curve and act on those things versus trying to have a static definition that applies the same everywhere, and that static threshold may be fine most of the time. And at the time that it does trigger, it may be too late. Okay, so let's look at some key takeaways and lessons learned. You'll notice this bullet of do not do this in silos will be at the top of every key takeaway. That is an important thing to ensure that you don't let silos get in the way of your success. Every one of these things, and make sure that you want to involve other areas that are feeding or coming into in this case, coming into event management, which would be coming from the CMDB, which your models are in place, and more importantly, the consumer who's going to get the benefit from this. But a couple of things we pointed out here have to do with synthetics being complementary to your monitoring capability. We want to shift our focus from outages and just trying to keep things up and move more toward degradation. That's where that static versus dynamic thresholds come into play, and when you expand your focus around application monitoring versus in addition to infrastructure monitoring. And you should also pay attention to what you're monitoring and pay attention to what degree that you monitor different things.
Darius, there's a question in chat. Can you clarify what you mean by not monitoring everything at the same level?
Sure. What I mean by that is, for that bullet, what we're talking about is that all infrastructure items are not equal. All items in your environment do not require the same level of monitoring. So when we talked about the different levels of infrastructure, application, applying synthetics, you may want to take a step back and realize that there are certain key services and infrastructure that support those services that are more important than other services or other infrastructure items. And so you may decide that, hey, level 1 may be we just do infrastructure monitoring as a base for any server we put in the data center, which means we're going to monitor CPU, disk usage, memory, X, Y, and Z. That's a standard starting point for just getting the monitoring there. But for something that's of medium importance, we're going to go to the next level and we're going to add synthetics on top of it and understand what the steps are that are tying into that application so we can just get ahead of it in case the customers start experiencing things. That will be our level 2. And so when we pick out a service, we'll figure out whether we're giving it level 1 or level 2 level of monitoring. And level 3 says, you know what, we want to pay attention to this particular application. Let's understand where the choke points are. Let's figure out where the tipping points are in the architecture of the solution, or where the bottlenecks or single points of failures may be, and let's put monitors specifically targeted at those areas. That's a different level of investment because, in fact, that service, that application is one of your critical apps. You wouldn't apply that level of investment around every single app that exists in your environment. So one of the things to consider is to say, for certain items, we do level 1, level 2, or level 3, and make that a part of your criteria so that you're just not trying to do the overboard on everything, especially when you're not going to get that value back by having things monitored at the app level for things that are not as important to the business. Okay, hopefully that addressed the question that was had in mind. Let's move on to our next section. Knowing what you have, going through understanding how you can improve or establish clear insight into your environment through discovery. So having the context of what you have in your environment beyond just the items themselves, beyond just the infrastructure individual components, and being able to get them into some form of a model where if something goes wrong here, it has an impact of something else upstream that's important, goes a long way to moving that needle even further to the left. So let's see how that comes into play. Let's go back to our key building blocks and adjust the picture a little bit. Rather than just discovering individual entities, individual CIs or infrastructure items in the environment, we want to also be able to look at models and how things are related together. So we'll not focus so much on the right here and stay focused just on the foundation of information that will support the upstream activities of event management and service management. So know what we have and get it into our system of record so that it can be leveraged by event management and service management. So to that end, we'll introduce models as a part of the equation, and we'll see that the needle moves slightly to the left even further as a result of having that context. So again, let's provide a baseline here. You have different levels of awareness of what you have in the environment. You can start off with, especially in your event management space, things happen, you get an alert, and you trigger and just record that an event occurred. Something went wrong or something of interest happened that you want to record and maybe take action on. You may not even capture any details about the item or have it tied to a CI or an infrastructure item, but you just know something went wrong, it's an alert, and you kind of know where to go look at it, and you're just dealing with different alerts that are happening in the environment. The next level up is to have that alert and have a better insight or better context for it by knowing specifically the CI that the alert occurred against. And that CI is something that is represented in your CMDB so that you can associate it to your tracking system, to your incident, and do all the tracking and changing activities around that item as a part of your process. So level 2 is taking the event itself and associating with the actual CI that was discovered in your environment. Level 3 provides even better perspective. It gives you even more context. It's more than just what the item is, but if something happened to this item, what happens to it, how it impacts other things that depend upon it. That's where the models come into play. This is an example of a hierarchical static model or a hierarchical model. And this model is one that I want to be very clear about. This is appropriate, again, for your top level services or your top level apps. The goal is not to do this level of hierarchy for everything you have in your environment. This takes time. It's never done. It's always evolving because your application and your infrastructure underneath it is always evolving. So keeping up with it, managing it, maintaining it is definitely worth the investment for the things where it makes sense. But for other items, really all that's relevant is if this item somewhere in the tree has a problem, I know it affects this upstream app or this upstream service. And that can be represented in a more simple model, which is only 2 levels deep. Item below and the item up above that you care about. And just connect the items together and you still get huge value from that because if something goes wrong here, you know it affects the thing that you care about. And that is able to be leveraged in your downstream activities. Frankly, the best practice or the thing that I found effective with customers who have done this or looked at this these two different models before, is acknowledging that 80% of their landscape where models come into play are leveraged or represented as these simple models. And they're easily put together because, frankly, they can get that from spreadsheets. Most customers already know that these infrastructure items in some way connect in a way that's important to this upstream item. The remaining 20% are the ones that you invest in order to have the hierarchical model. And for those, you get some of the following benefits. When it comes in that you have an event that occurs against a configuration model, against a service model, you're able to understand that when something goes wrong, it will affect something that's upstream. So when you create the incident contains that information. Therefore, when a person gets an incident assigned to them as a service desk agent, you're able to have better context to know what to work on where, and more importantly, because you know about the service, you're able to prioritize what you work on first. Therefore, you're not just doing a first in, first out on any incident that comes in. These incidents can now come in with an understanding that it affects an upstream service or application that is critical to the business, more so than the incident that came out against the server that supports somebody's lunch application for that division of the company. So let's just see that at work. What is the then benefit of when you go to a hierarchical model? Hierarchical models allow you to understand and take into account clusters and redundancy in your environment to know that when something does go wrong, does it really affect the upstream application or service? So we may start off with an item as you see to the right, which is the basic CI. The CI comes in the environment. Knowing that there's a CI is interesting. When something goes wrong with that CI, which is level 2, it may turn red. Well, only thing I know is that the CI turned red, and I probably should fix it. But this CI is no different than any other CIs because I don't have any context for it. If I move forward and get a more comprehensive view, turns out that particular CI fits into this model, and more importantly, it's behind a redundant environment. It is one of 4 CIs, one of 4 servers that are supporting the next level of capability that ultimately supports the service that I've deemed as important, which is order management. So in this case, when this item turned red, yes, it's going to be important that I fix it, but I have some context to know whether I'm fixing this or something else that's affecting an upstream service because I know I have redundancy here. I've only lost 25% of my capacity. And ultimately, I do want to take care of it. But time goes on, and next thing I know, another server underneath that redundant environment is impacted. But I still have 50% of my capacity. What you're able to do in event management systems is say, when I lose more than 50% of my capacity, that's when I care about making sure that this becomes a higher priority than other things. In this case, don't get me wrong, you still want to get on top of these items. But if there's something else going on that has a larger impact, these would be lower in the queue because you still have coverage, the upstream service hasn't been affected, and more than likely your customers are not seeing the impact. At best, they're seeing some maybe minor degree in degradation. It's when you lose more than 50% of your capacity that you want the system to reflect the fact that, okay, I've got a notable thing going on here, which I may want to represent as an outage. And therefore, I elevate working on these 3 items at a higher level, as a higher priority, The key thing is that when I saw it the first time, I saw the first CI. If I fix that CI, I would not have even had this problem if the second CI went down. But when I get to a point where I lose more than 50%, in this case 3 out of the 4, that point I'm now in reaction mode because more than likely I'm now at a point where my customers are seeing what's going on. So this is an illustration that you want this level of perspective, this level of insight, this level of context for applications that matter, that are the important applications in your environment. You wouldn't necessarily have this level for everything that's out there for your service models. So what are the key takeaways here? When you look at service models, you really want to take a look. The key things out of all these bullets, you can note these yourself. Hopefully most of them are self-explanatory, but I'll call out 1 or 2 of these. You want to take a top-down approach when you start looking at and trying to decide what services that or applications that you want to apply hierarchical models to. You want to look at that and understand what are the top level capabilities. Notice in this example, we talked about order management, and you want that from the perspective of the business. You don't want to limit your ability to determine what is the model that supports that business by what IT does from the bottoms up, because the terminology from the business is different than the terminology that IT uses for infrastructure items like servers and routers and load balancers and things like that. It's a marriage between those two that are key. Again, don't operate within silos. The business will tell you that it's order management underneath there. There's certain functions in order management that give me capability for the overall service, and then you can attach your infrastructure to those functions. But you want to do that from the top down versus trying to do that from the bottoms up. Another point that I don't want to lose here is that when we talk about these static simple models, it doesn't mean that those static simple models may not ultimately be converted into hierarchical models. So it's not an either or activity. It's an activity where you start off with this to get something in the system to have some basic model beyond just an infrastructure. But at a certain point, you may say, hey, look, this is now one we want to evolve into a hierarchical model because we've determined that it's a priority.
Darius, I have a question in chat. It says, you show 3 levels. Would these be implemented level 1, 2, and then 3 sequentially? Or can you go directly to level 3?
That's a really good question. And there's 3 points I want to make here. Let me start off with this one. The first one is level 1, 2, and 3 is not intended to reflect that when you go from level 1 to level 2, that you've left level 1 and you're not doing any more of level 1 activity. And when you go from level 2 to level 3, that you're not doing any level 2 activity. For most mature customers, when they get to a level 3, they're actually still doing things that are coming in as just events. They're still having things that come in as just infrastructure items, and they also have items that are being supported by models. So it's not a leave from 1, go to 2, and then you're no longer doing 1 because you've taken all of your events and you've associated with them with CIs, or that you've gone to from level 2 to level 3 and every infrastructure CI has now become a part of a model. That would be something you would strive for, but it's not a criteria that limits you to getting into level 3. Level 3 will be in play. There will still be things coming in that are at level 2, and there will still be events that come in that are still valuable in your operations. That's part 1. Part 2, starting at level 3, if you haven't done anything at level 1 and level 2, would be a mistake. It's not that it cannot be done, but the things that you do at level 1 and level 2 contribute to efficiencies and effectiveness of what you do at level 3. So the short answer targeted at that question would be, yeah, you can come in at level 3, but you will not be as effective. I think you will find that you will probably make more mistakes in trying to get things all done at the same time, while at the same time of getting models together, and it'll be a harder road to go down, just because you're focused on models. And this is the third point, which is really building on the previous one. The benefit of coming in and starting at level 1 to kind of make sure you have your end-to-end things in place goes back to that first bullet. A lot of the things that go on in the environment is breaking down the silos to understand that I am going to move information from one practice area into another practice area. When you're starting at level 1, you're just trying to open up the pipe and establish the pipe for events, and the right events to be showing up in your incident management system. Commonly what happens is you turn on the event system and you say, I've made the integration connection, and all of a sudden these incidents get flooded, or the service management system gets flooded with all these events. And the point is that you want to do event correlation and consolidation so that you only escalate or you only result in the events that are not redundant and only create incidents in that case. That's a learning curve there. There's some activity that has to be done in order to make sure that that's done efficiently and effectively. There's a certain level of processes that are established as you're working between the practice area of event management and service management, more specifically incident management. But at least you have that pipe open and you've worked that out. Now, when you go to level 2, you're now making the connection between your system of record with your CMDB. And from the CMDB, that got populated from discovery. So that foundation set of information is being put together, and you're working on establishing the effectiveness and the efficiency of having your discovery flow to your system of record, and then for your event management system to get the information from your CMDB. That's another channel of information. So for level 2, you're getting that pipe established. You're getting the efficiencies between config, discovery, and event management established and in place. that complements what you've already established now between your event management and your incident management. Because now when the data flows into event management, you have an event occur, it will now create an incident, but you've already established the effectiveness and the efficiency of getting the incident created. Now that you have that foundation in place, and you now start doing things at the service level, you're building upon the channels that have already been established. And there's going to be a lot of shift in thinking in order to make sure that you have models built in a consistent way and models built at the appropriate level for the apps that you're going to focus on. Working with the consumers of the information to determine what are the apps and what models are appropriate for that. That in and of itself is going to be a focus area. But when you're doing that on top of the fact that you've already established your efficiency between discovery to configuration management activities and that to the event management and also building upon your event management to incident, those foundations are already in place and things are already flowing between there so that when you apply the benefits of your service model, you're not running into the issues that complicate your effectiveness by trying to figure out why a CI didn't show up in event management the way it should have. You've already addressed that because you had to do that as a part of level 2. So that's a long-winded answer to the question about starting at level 3. The short answer is yes, you can. But I don't think that you'll be as effective, and the journey will be a lot more difficult, and you'll make I believe have a bit more of a challenge trying to handle models plus connection between event management and incident management, and your connection between discovery to CM configuration management and the things that are naturally and expected to go between between configuration management and event management. You'll be trying to do all that at the same time if you're just trying to start there. And even if you've done a little bit of that before, I would say go back, take a look at the first step in phase 1. Let's make sure that channel is efficient between event management and incident. Once you get that solid and clean, go over to discovery, into config management, and how that feeds into your event management solution. Even if it's just a review of what you already have, establish that those things are efficient, so when you're doing the service modeling, it's already taking advantage of your foundation. Okay, let's now move on and go into that area that says, what does it mean to get in front of events before they even occur? What we're talking about here is even having the capability to look forward or doing some predictive activity that allows you to put things in place to prevent an event from occurring in the first place. There are several solutions that help with that. Problem management is an obvious one, because what problem management is all about is looking at trends that are going on in the environment, be that in incidents, be that in events, but you're looking at things that are going on that seem to be repetitive in nature, and you're trying to understand why this thing is happening over and over again. So if something's happening once and you fix it real quick, that's that break fix reactive mode of operation. Or even if you're doing it in the degradation mode, well, we know what this is and we just fix it right away. That's fine. But if I'm doing it every hour or every 2 days, at some point it may turn out that becomes a larger issue and a more notable event, which may lead to an outage. So understanding those things and being proactive and looking at trends so that you can get in front of them before they become larger issues. An example of getting in front of something before it becomes a larger event, which leads to an outage. Change management is another notable example. With change management, this is the practice, which everybody knows, but it's the practice of making sure that what you're going to change goes through a review process. It's the governance portion around it. There's some quote done a while ago where a large percentage of the problems that IT runs into are self-inflicted. That's because when they're trying to make a change, they're not aware of the things that are happening upstream or downstream. As a result, they created the situation that led to the event. If change management is done in such a way where you leverage the benefit of discovery and the config management to know the context of things, so when you make these changes, you're doing your appropriate reviews, your checkpoints, and your approvals, then you get things done right the first time, which doesn't lead to an event. And another example is capacity management. Understanding what you're doing today, applying that to what you plan on doing tomorrow, and then doing the predictive analysis and activity to say, knowing that we're going to be doing that later, I'm going to get in front of this, put more capacity in place so that when I get to that point, I don't have the system come up short. So some of the key takeaways here have to do with leveraging change management to drive these kinds of shifts in thinking. Thinking about reactive to proactive is one thing, but how do we get in front of things before they even become events in the first place? a natural place to do that is get people thinking about the benefit and understanding the strength and value of change management. And once people start understanding that an efficient and effective change management process helps you reduce and has a direct correlation to reducing the things that affect the stability of your environment, allows them to be more open and receptive to other things that can be done to get in front of issues. There's examples of this is challenging the customers or challenging folks to, changes is a process, but if you don't know what you have in your environment and you're making changes to it, you don't know based upon the fact that you have discovery, feeding your config management so that you understand the impact of something upstream. You're not relying upon what people know in their head, but you're leveraging it based upon data in your system. That's a very effective way to get results that you can tie back to having people change the way they look at things. And another note here is things will happen. Reactive to proactive is what you want to do. You want to reduce the frequency of outages, but life happens. Things will happen. It's oftentimes a lot of energy just to get over the crisis that just occurred. But once that crisis is done, take advantage of problem management to do root cause analysis to understand exactly why we got here. Put as much energy around that activity as was put into getting over the crisis in the first place. There are oftentimes customers get past the crisis and are just at a point where they just want to take a deep breath and go back to doing what they were doing before because the crisis has been now resolved. That is the most critical time by which you want to do your root cause analysis and then start trying to figure out what we could have done in order to prevent that from happening in the first place. That's where problem management becomes key to your activities in this goal. Now, the cherry on top of all of this is as you start going into detecting things better, as you start getting in front of things because they're degradations versus outages, the very key thing around this that comes into play now is how do I remediate? Once I find something, if I can leverage automated remediation to get things in place for the things that I know how to fix, that moves the needle even further to address the gap that may occur in getting things back up and running when the failure occurs. For example, if I look at something that comes into the environment and it turns out that I get an awareness of it because it starts degrading, and we have the foresight to look at this and say, from the time that occurred, an hour and a half later, the system failed. Well, as long as I can solve that problem within an hour and a half, then I'm okay. Automated remediation puts you in the position that it puts efficiency into fixing things quicker so that you can have more opportunity to getting things back to the steady state that you expect them to be. So it's the building block. It's that top layer that sits on top of once you know what you have. It feeds into your system of record for your configuration management. Events detect what's going on in your environment. When there are things of relevance that require attention, you feed it into your service management system to record that activity so you have your governance around it. And where appropriate, you can kick off automated remediation to resolve the issue. Remediation is what you do in general within incident management, but leveraging automation, you introduce efficiency in getting it fixed sooner than later. And hopefully before it results in an outage. Remediation can be applied at all stages that we have here on this chart. It's oftentimes that remediation is aggressively applied in the reactive mode of operation because they're getting better at fixing things faster as opposed to looking to the left and thinking, what could I do to get in front of that item before it occurs at all? A very healthy investment is during the time when degradation occurs. What remediation can I do to make an attempt to resolve this issue? Do I flush the cache? Do I go off and reset a particular service so that it comes back up and things get cleared out? And finally, on the area of proactive event mitigation, capacity is the classic example. Once I know that I'm going to use this capacity now, but down the line I'm going to be doing more work later, that's going to require more capacity. My remediation for that is to put in a change and plan for getting the capacity necessary to support where I will be before I get there. Again, you'll notice at the top, all of these discussions should not be done in silos. They should all be done in a collective and a collaborative fashion, working across the different practice areas to ensure that you're getting the best results that you need. Another key point here, if you're able to detect the event at the time of degradation, but you only catch it 10 minutes before it leads to an outage, then we haven't had much gain in our ability to be proactive. Even if you catch the event 5 hours in hindsight, We know that it's 5 hours before the actual outage occurs. If it takes me 5 hours to solve the problem, the outage still occurred. So remediation, automated remediation, and my efficiency to solve the problem is a very key and valued capability here. But the sooner I find the issue at the time, from the time the event occurred, then I'm in a better position to get it resolved before it results in an outage. And finally, all of these things can lead to some valuable things. Where do you start? There's a lot of components that are going on here. Please consider taking a step back and starting in a focused area. Identify a consumer, look at that consumer end to end, not only from the technology that needs to be in place, but also the processes that need to be in place to support that consumer's needs. The governance that needs to be in place. How do you get information from them from a people process side, and how you guys work between the organizations in order to get the results you're looking for. The really important point behind this is while you pick that initial consumer, your goal is to have a good first impression, because once you get a result across all these different practice areas that yields to a benefit, it allows you to promote this and then start influencing other areas to make adjustments to what they're doing for the benefit that you just demonstrated. If you're going into an area and just saying, trust us, do these things, you'll see the benefits later. It's sometimes hard to get those adjustments made in the people process side of things. If you pick a friendly consumer or a consumer that has the most issue and is very eager to do something to get better, pick whichever one makes sense, but starting within a focused area and looking at that opportunity end to end for that consumer's need. Understand what infrastructure supports their capability. Representing that in the CMDB with first maybe just the items, the configuration items that support their area. Ultimately maybe put it within a model. Put the monitors in place that makes the most sense to them, and then tune those monitors to deal with potentially dynamic thresholds, or put the monitors in place around the applications and the bottlenecks inside the applications. Make sure you work on the people process side so that you start making sure you get feedback from those consumers as you're putting this end-to-end capability together. And more importantly, before you even start this off, you want to start with some baselines to know where you started in your capability, how reliable was the environment before you started down this path, so that when you start getting results, you can tie those back into the benefits that you can share with other areas that you plan to work with. So when you all come together, we look at these different areas of practice that we talked about: automated discovery, configuration management, event management, and IT service management. BMC has a set of products that has a role in each one of these areas. And that's what we have here that illustrates the different products that are available to support the different practice areas. May not be all BMC products, because that's why 99% of this discussion was about the practice and the capability in general. The technology is what you layer on top of how you approach this. I hope you all found this beneficial and got value from the content that we presented here. There are some other sources here that will allow you to get more information. Greg?
Now I will take us through the closing, some self-help and contacting BMC. Our videos as well as this webinar recording are available via our YouTube channel. Once this information is posted, it is reflected in our Connect with BMC, Helix, ITSM, and Remedy schedule, available at this communities link, as well as the product support pages that contain different videos, documentation, knowledge articles, combined based on product component. A very useful resource available 24/7. And as always, our technical support methods of contact via web, phone, and email, as well as the social channels as well. Thank you.